Okay, let's go ahead and start. A plus 7 millicoulomb, milli is times 10 to the negative 3, millicoulomb charge is attached to a spring of spring constant 2,500 newtons per meter. A second charge of unknown magnitude is brought 65 centimeters from the first, and the spring compresses 12 centimeters. What's the magnitude of the second charge? So here's our 7 plus 7 millicoulombs attached to the spring, attached to a wall. We bring another charge. We don't know what it is. 65 centimeters away, and the spring compresses 12 centimeters. Okay, how do I do this one?
Well, you know that the other charge is positive.
Okay, one good bit of information. The other charge is positive. Positive charge. It repels the this charge right here and makes the spring compress. Okay. So, let's do this. Let's draw.
So we need to find the force between the two charges.
Right. This is going to involve force. Okay. If I do a quick little free body diagram on this guy, I've got two forces acting on, right? I've got the spring force and I've got the electric force. Electric force is pushing him that way. Spring force is pushing him that way. So F electric, F spring. Okay? Now, since this particle is at rest, okay, it's not moving, not accelerating anything, what do we know about those two forces? They are equal. They are equal. Okay? So I'm going to set them equal to each other and solve for my stuff. What does the force do to a spring? Anybody remember the equation for it? Okay, negative kx, okay? Now the negative part of that equation, by the way, just tells us direction, so for now we're going to leave it off because we already know direction. So k, 2,500. X is 12 centimeters, so let's put it in meters, 12.12. Equals electric force. Which formula for electric force are we going to use? Right, Coulomb's law. We have a choice between K, Q1, Q2 over R squared, and F equals EQ. But this says nothing about electric fields, so Coulomb's law is the better choice. K, 9 times 10 to the 9th. Q, let's see, Q1 is 7 millicoulombs, so 7e negative 3. Q2 is unknown, that's what we're solving for. So just leave it as Q. Over R squared, the distance between them squared, so 0.65 must be in meters squared. Okay, so solve for Q. You divide both sides by 99.
Is it 2.01 times 10 to the negative 6?
Sounds right to me. 2.01 e negative 6, you said?
Yes.
Coulombs. So 2.01 microcoulombs is our answer. Okay? Does anybody have any questions? Okay, let's go on. Am I good to erase? Erase. I've got to erase my alligator, crocodile, whatever it is, Komodo dragon.
You haven't even erased mine yet. It's a miracle, guys.
What's the picture?
Well, it's not in the camera shot, so I don't need to
It's
erase it.
never in the shot if you erase my whale.
Shout out.
What?
What's the picture?
It's the crocodile. It's the imprint of a crocodile in the sand. There's no steps leading away from it, so they can either fly or teleport.
No, if they were to fly, they'd have to like run in order to get flying.
What? Okay, anyway, part R. A plus 2 coulomb charge and a plus 3 coulomb charge are separated by a distance of 1 meter. How far from the plus 2 coulomb charge will the electric field be? 0. By the way, this one is very, very similar to one on your homework.
Oh, cool.
So, helping you out a little bit here. All right. So, here's our plus 2 coulomb charge. Here's our plus 3 coulomb charge separated by a distance of 1 meter. Okay? Now let me remind you, the electric field, first of all, it is a vector, and second of all, it goes out from positive. So looking at these two positive charges, I can see the electric field goes out from one and out from the other. So they're facing opposite directions, right? Electric fields are facing opposite directions, at least between them. So what do vectors do when they're going opposite directions? What do vectors do? Like if I had a force this way and force this way. Okay, they subtract from each other. And if the magnitudes are equal, they will completely and totally cancel. Okay? Everybody kind of get what I'm saying? A little bit? Okay. So, in between these two charges, there is a point where the electric field from the 2 Coulomb charge equals the electric field from the 3 Coulomb charge, and they will completely cancel. All right? Now, I'm going to call that point a distance r. Okay? A distance r from the 2 Coulomb charge. All right? So, what does that mean this distance is?
Is 1 minus r.
Right. 1 minus r, whatever's left over. 1 minus r. Okay? So what I'm going to do is I'm going to solve for the electric field at this point due to this guy, and set it equal to the electric field at this point due to this guy. Okay? And whatever distance I solve for, whatever r, that's the point where electric field is 0. So, electric field, let me remind you, is kq over r squared. It's missing one of the q's. Alright? Q is 2 over r squared equals kq is 3 over r squared, but let's be careful. This is my distance, not this guy. This right here, 1 minus r. So 1 minus r, all of that squared. Okay? What do you notice right away? Case cancel. Thank goodness. No dealing with 9 times 10 to the 9th anymore. Alright? And we're solving for r. Okay? So all we have to do is cross multiply here. Multiply by this guy, multiply by this guy. I get 1 minus r all squared times 2 equals r squared times 3. Now, quick question. Can I distribute this squared to get 1 squared minus r squared? I cannot. Okay? The only time you can distribute a squared is when you are multiplying. Okay? Like if I had x times y and I squared all of that, that is the same as x squared times y squared. Okay? That's allowed. But if I had x plus y and I squared all that, that is not x squared plus y squared. What do I have to do when I have a x plus y squared? The box foiling, I have to foil. Okay? First, outside, inside, last. Okay? So this would become, first is x squared, outside, inside gives me plus 2xy, last is y squared. Okay? So remember, you cannot distribute the squared if you're adding. We're subtracting, which is the same as addition. We're adding here, so we cannot just distribute. We got to FOIL. So let's do that real quick. First is 1 squared, which is 1. Outside, inside gives me minus 2r. Last, I have negative r times negative r gives me positive r squared. Times 2 equals 3r squared. Okay? Now can I distribute this 2? That I can distribute because it's just multiplication. It's not an exponent. Okay? So let's distribute this 2. Alright, I'm going to get 2r squared. I get minus 4r, and I get plus 2 equals 3r squared. Okay? Now what I'm going to do is I'm going to get all my r's on one side. Okay? Well, actually, I'm just going to get everything on one side, and I'll have it all equals 0. Okay? So I'm going to subtract 2r squared from both sides, add 4r to both sides, and subtract 2 from both sides. to get 3r squared minus 2r is r squared plus 4r minus 2 equals 0. Whew, what do I do from here? Oh, I would factor. That is the right approach. Unfortunately, that sucker does not factor. So I have to use what? The quadratic equation. Opposite b plus or minus the square root of b squared minus 4ac all divided by 2a. You got that?
No.
Opposite b, okay? Take whatever is multiplied by the one variable minus 4. Plus or minus the square root of 4 squared, 16, minus 4 times a. A is the coefficient of the r squared term, which is 1, times c, the coefficient that's just there, minus 2. All divided by 2 times a, 1. Okay, so those are our solutions. So minus 4 plus or minus the square root of 16 minus negative 8 is 24. So that over 2. I can actually pull a 4 out of this. Square root of 4 becomes 2. So if I divide both sides by 2, I get minus 2 plus or minus square root of 6. And there we go.
It's
Yeah.
supposed to be a warm up.
Yeah, it is.
I'm already hot.
Is that the answer to everything?
It's not warming up right
Once
now.
you're here, everything else is just math. Right?
That's the hard part.
Yeah, right here, this is the hard part. Then you got math. Threw my pen on the ground. Woo! Okay, anybody have any questions? All right. With the rest of the class, we're going to do some practice problems out of our lovely workbook. For you at home, I'm going to post pictures of the workbook and solutions. So, have fun with that. Okay? Anybody have any questions before we go?
Go about it.
Sure.
I
Bye.
have a workbook.